Welcome. This video is going to talk about section 11.2 from our book, which is discussing graphing techniques. Graphing is an effective way to communicate the effect of your independent variable on the dependent variable, and it can easily show physical quantities, and especially the difference or trend in those physical quantities. A sketch graph has labeled but not scaled axes, so it just shows your qualitative trends and is much quicker to draw. A drawn graph, however, has labeled and scaled axes, so it shows your actual data points and gives quantitative measurements. So more typically, we use drawn graphs, but especially on paper 2 and 3, you may be asked to sketch a graph and just show the qualitative trends. But often a graph is the best method of presenting and analyzing your information. Gives a visual to your talking points. Just some basic techniques. The independent variable should be graphed along the x-axis, and your dependent variable should be along the y-axis. Your graph should then include a title, your labeled axes, your quantities in linear amounts, and you should use all your space effectively. Your graph should take up the whole page allotted. And you may or may not include the origin on your graph depending upon what your range of data is. Often it's to your advantage to be able to plot your data in a manner that will yield a straight line. If you're getting an exponential curve as you graph it, you may want to try to plot the inverse of one of your variables, and that often will yield a straight line. The straight line, or with data points yielding a straight line, you can then put in a best fit line, which will allow you to either extend your graph to extrapolate or to interpolate and estimate between two of your data points. You can find the slope of a linear graph quite easily by drawing a large triangle. And if you have a curved line, then you have to draw a tangent line and work off the triangle from that tangent line as shown below. Systematic and random errors can often be seen on a graph of your data versus the perfect data or your best fit line, because random error will show up as data points both above and below the expected line, while systematic error will either shift the line above or below the expected. The other thing you'll see when you graph your data is any outliers, which will suggest or show how reliable or how repeatable your data was.